our video on chapter 14.6, measures of a spread. So we are still working on analyzing data. We're talking about summary measurements. We have already covered central tendency. So today we're going to be talking about spread, okay? When we're talking about spread, notice that we can't have any measures of spread in categorical data, okay? So we can't have that. We don't have any measures of a spread in categorical data. But when we're talking about spread in numerical data, we can talk about standard deviation and interquartile range. Now, in the same way that this one is better when you have a symmetric distribution to use a standard deviation, is more useful, and it's more useful to use interquartile range when we have a skewed distribution. Okay, so let's talk about what measures of a spread they exist. We're going to talk about 3 measures of a spread. And I already have measured 2. So the first one that we're going to talk about is the range. So the range is basically just taking your maximum value and subtracting your minimum value. So it's just saying from the top to the bottom, how spread is that data, okay? So that's basically the range. How spread, what is my range of my data from my maximum to my minimum, okay? The second measure of a spread that we're going to talk about is the one that is written here. Interquartile range. I'm going to write the abbreviation, which is IQR. And the third measure of a spread that we're going to talk is a standard deviation. That the symbol for a standard deviation is a sigma. It's like this. So I'm going to explain these ones here. So let's take this one first. We need our box and whiskers to explain interquartile. So I'm going to explain this one first. So first of all, girls, I need you to fix the previous video that I did on box and whiskers, because I called the lower quartile Q2 and this one Q3 and this one Q4, and those names are wrong. So you have to put lower quartile is Q1, median, and Q3. Okay, girls? So just fix that in your video, por favor, in your notes, please. Okay, first thing that I want to explain here. Interquartile. So box and whiskers, this name quartile comes because it's talking about quarters. So if you remember your video on Maths Online, it explained that you were dividing your data into quarters. So basically that's saying that I have from the minimum to the lower quartile, I have, my goodness me, 25% of the data. Okay, girls? And from the upper quartile to the max, I have also the 25%. And here from Q1 to the median or to Q2, I have also 25% of the data. And here in this also, I have also 25% of the data, which means that inside this box, I actually have 50% of the data. So all of this will be a total of 50% of the data. And the interquartile range is basically the difference between Q3 and Q1. So that's what I'm going to write here. This one is Q3. Take away Q1. So basically, you're focusing on the range of only this data here. I'm going to use a different color, of this data here. Okay, so I want to explain something here, girls. Let's say that I have a box and whiskers like this. Like this. Something like that. I'm going to exaggerate this a little bit more. And I'm going to fix this. Okay, what is happening here? So I have 25% of the data here, 25% of the data here, 25% of the data here. That means that in this bit, I have 75% of the data. And here I only have 25. If I have a histogram of this, it will be something like this. The data is concentrated on this end and it goes boom. Something like that. Not exactly, maybe not as low, but something like this. Like maybe something like this. Wow. Something like that. Agree? Now, if I have the opposite on this side, so on this side, I'm going to exaggerate again. So I have this side and I have my box here and then my other whisker. So again, I have 25 and 50% here. So 75% of the data is concentrated on this side. So it will be something like this. This is what is called skew data. Okay, girls, but I want you to focus on something. Remember that the interquartile range only focuses on the difference of this data. The range between this data of that 50% is not taking into account minimums and maximums. So these two different data, they're very, very different, could have very similar interquartile range. Okay, because in the interquartile range, I'm only using the difference between Q3 and Q1. Okay, fantastic. Now, the other one that we're going to talk about is a standard deviation. I'm not going to give you the formula for a standard deviation because you're not going to be calculating the standard deviation by hand. You're going to be using your CAS. So to explain a standard deviation, I'm going to use a graph. A graph that you're going to use a lot later on in another year level. So this is called the normal curve, and it's very, very useful. You're going to learn a lot and going to be using it a lot. But the important thing about this one is that it's symmetrical. Look, if I find this one is my median and my mean as well. So this is my mean. Here it is in the middle, and it's perfectly symmetrical, the left to the right. In this example, they're talking about test results. So let's say that we're talking about test results. So the standard deviation is basically going to give you how spread the data is from this central value, from that mean, from the average, how spread the data is from this center point. I'm going to rub it out like this. From this point, okay? How spread it is. So basically when you are finding the standard deviation, you're finding distance, girls. You're finding, so here you can see they say this data, like 34.1% doesn't matter, but it's saying that is, this is the distance. I have here one standard deviation and here is the data. Okay, so how much data I have here. Okay, how spread this data is. Okay. And then we have a second standard deviation here. And it's how much data do I have in here? And then the third standard deviation, how much data do I have in here? Okay? And same thing to the other side. Okay, girls? So this, if we're talking about tests, you will say, oh, yes, poor performance. Yes, I have very few people that got results in their, let's say, 10%. Agree? And very few people that had results in the 90%. So it's very symmetrical, this, okay? Now, if the standard deviation is small, what happens is I have very concentrated data. The data is very close together. It's very, very close. You can see here, it's very, very close. So most of the data is concentrated here. Boom, 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 boom. Very, very close together. Whereas if I have large standard deviation, then the largest, the more flat this curve is, the more spread that I have. Okay? Wonderful, girls. We're going to continue in the next video doing some examples.